This lesson is sponsored by Countless Raspberries. Raspberries, the premium fruit of the zombie apocalypse. Okay, in the previous lesson we talked about empirical formulas and molecular formulas. And that seemed to be relatively easy. And this lesson goes on to the next concept, the concept of limiting reactants. Now, limiting reactant, in order to do these problems, we need to know some basic knowledge of balancing chemical equations and mole ratios. But assuming that you know that knowledge, here we go. Okay. In a fine example of limiting reactants, we have nitrogen gas can be prepared by passing gaseous ammonia over solid copper oxide at high temperatures. The other products of the reaction are solid copper and water vapor. If a sample containing 18.1 grams of ammonia reacts with 90.4 grams of CuO, what is the limiting reactant and how many grams of N2 will be formed? Okay, so in this, we've already balanced the equation, but remember to never forget balancing the equations. So we have 2 moles of NH3 reacts with 3 moles of CuO, which leads to 3 moles of Cu plus 3 moles of water vapor plus 1 mole of nitrogen gas. Okay. So we need to determine which is the limiting reactant, NH3 or CuO. In order to do that, we have to look at mole ratios. Okay. The problem gives us that 18.1 grams of NH3 is reacted with 90.4 grams of CuO. Let's take this process slowly, really absorb it in your mind. 18.1 grams of NH3. We need to know how many moles that is. 18.1 grams of NH3 using molar mass, 17.03 grams of NH3 is 1 mole of NH3. That leads to 1.06 moles of NH3. Okay, doing the same with CuO, we find that 90.4 grams of CuO equals 1.14 moles of CuO. Which is limiting? 1.06 moles of NH3 or 1.14 moles of CuO? Okay. Now, there are 2 ways to do limiting reactant. I'll do the first easier way, but if the first easier way doesn't make any sense, I'll show you the next way. Okay. Okay. In our above equation, let's look at CuO and NH3. Okay. That's a 3:2 ratio. What about in our calculated ratio? It's 1.14 to 1.06. In the real ratio, it's moles CuO to moles NH3, 3:2, 1.5. In our calculated ratio, it's 1.14 to 1.06, 1.08. Here we go. These 2 numbers are very important. The actual mole ratio of 1.108 is less than 1.5, which means CuO is the limiting reactant. Let's think about that for a sec. In our actual ratio, it's 1.08, which means CuO moles is less than NH3 moles. If CuO moles was greater than NH3 moles, 1.08 would be greater than 1.5. Okay, that is confusing, but let's go on. If that made sense, then CuO is the limiting reactant. How do we determine the number of grams of N2 formed? We just use the calculated CuO moles, 1.14, and use the mole ratio of CuO to N2, which is 3:1. Calculate number of moles of N2, 0.3 moles of N2, use molar mass, boom, here we go. That's how many grams of N2 are formed. Okay. Now, to use the more traditional way of determining which reactant is limiting, here we go. Alternatively, we can determine the limiting reactant by computing the moles of N2 that would be formed by complete consumption of NH3 and CuO. So we calculated before that 1.06 moles of NH3 formed compared to 1.14 moles of CuO formed. Okay, so now we need to calculate the complete consumption of these both. So using the mole ratio of NH3 to N2, the gas we want to know how much is consumed, we just do the mole ratio. It's 2 moles of NH3 equals 1 mole of N2, which equals 0.530 moles of N2. Same thing for CuO. It's just, these are all coming from the balance equation. So just look at the balance equation for the mole ratios. 3 moles of CuO equals 1 mole of N2. That produces 0.380 moles of N2. As before, we see that CuO is the limiting reactant since it produces the smaller amounts of N2. And then likewise, we could use moles of CuO, get moles of N2, get grams of N2. So that's how you determine the limiting reactant in these kind of problems.